So on a previous video, we looked at how to generate a SUMO readable edge relation file using a Python script. So there we've discussed in detail how we can set it up this for to include your traffic counts into your traffic simulation models. Now that is mainly for general vehicles. Now when we say general vehicles, those include cars, vans, motorcycles, or any other vehicle types. So it does not include public transport modes. Now in this video, we are going to look at how we can include public transport demand also into your traffic simulation model. So for that also we need to do something similar, but when you consider a public transport mode, you have some more additional elements to consider. Now, first of all, there are bus stops involved in this operation. Now, for example, if I may show you the network that we have, and if I load the bus stops that are there in this network, so I can go to in SUMO Net Edit and go and load additionals and navigate to the place where the bus stops are actually stored, right? So in SUMO, you can create bus stops as an additional file and separately save it in a particular location. And then so once you load it, you can see these bus stops. Right, so if you inspect one of those, now this is the first bus stop that I will find in my network. So it's at the cross junction. So you can define all the bus stops along the route, right? And in those stops, your buses will be stopped. Now the other point is how long a bus will be stopped, or the duration of the stop. Now that also you can assume, let's say, an average value, or else if you do a survey, you can actually get the stopping times of certain buses or all the buses in your network, or maybe if you do your survey for a sample time period, you can get those stopping times, and then from that you can sort of fit it into a distribution, and from that you can also find the appropriate stopping times. So we'll come back to that separately. So we discussed stops and stop times, and the next important thing is the bus routes, obviously. Now if you look at this particular network, this is the first stop in my network, and if you check that particular stop, you can see a lot of bus stops are moving, are in operation. So you can see now, broadly speaking, we can categorize this into, at least in this corridor specifically I'm speaking, you can categorize it to short distance bus routes and long distance bus routes. And so different bus routes, okay, or have different behaviors, right? For example, now if you take this, in this particular segment, bus number 100 and 101 has very short headways, whereas 183 bus will have a bit of a longer headway, and these other buses, like starting from the number 400, are actually long distance buses. So if you consider all the long distance buses altogether, they will have a shorter headway, but if you consider them individually, they will have a shorter a longer headway. Now we need to incorporate that headway characteristics also when it comes to generating the public transport trips. Now, as you can see, it's not similar to what we did in general vehicles, but there's a bit more complexities. Now, the way that we show it in SUMO, or the way that, or the output file you need to get is in form like this, right? So you need to give your, or create your bus strips XML file in this particular fashion. Now, there you have a couple of elements to consider. First is a unique ID for the bus strip. The next is at what timestamp, or what simulation timestamp the bus will be enter into the simulation, and from basically the route information. Now here they are giving, in the documentation they say the incomplete route definition, which will work for this case, because this is a straight corridor which doesn't have any other other potential path for the bus to travel. So therefore it will work. If not, what will, as per the documentation says, it will yeah uh, yeah, it was said somewhere here that if the traffic volume is too much, then the bus will try and find its way uh, using other potential paths, uh, if you set things up like that, like this. But in this case it doesn't matter, because it's a straight corridor, right? So we'll stick to this particular file format of generating the output. So here, if you see, as I was saying, you have the ID, the type of the bus. So in our case, this can be a short distance bus or long distance bus. And there are other bus services, like in the morning you have office transportation and school transportation. So depending on the different types of operation, these buses may have different characteristics. So there you can bring those as much as possible. And the starting edge of the route and the ending edge of the route can be defined. And then you can also define for a given trip what is the order of the stops and how long that a stop will be made. Now, here we are going to consider all of them and going to create our uh, bus strips XML file. Right. So to start with, we'll create a Python script, and so I will create a Python script inside this, and later we will move it into a particular location. So here I will open a Python script. Let's say generate bus strips. Right. Now, for this, actually, first we need to get an idea of the stop sequence. Now, for a given bus route, you will have, like, certain, in this route, buses will stop at certain locations, right? If you consider another route, maybe the stopping order might be different. So we need to take that into consideration, because at the end, we are going to, for a given bus trip, we are going to mention the stop order. Now, so that can be get from the field data, or else you can also get it from going through these, a map, and then check each bus stop, and you can get an understanding what in what, on what bus stop, what routes are stopped or will be served. So from that, you can get some idea on that. But in our case, we got the data, I mean, from a survey. We Those data actually was taken as video recordings, and then later they were processed manually, and there we took the details about when the bus, or rather what's the bus route, what's the type of operation, when the particular bus came to the bus stop, and how long was it stopped, and when it took off, and then some information like that. So if I may show you that to you quickly. So this kind of information was collected, right? So for example, we collected the bus license plate number, the route, whether it's a short distance or long distance, you can get it from the route itself. And also the arrival time. Sometimes the buses won't be stopped, so there won't be a timestamp located or recorded here. So the boarding number, lighting number, and the departure time, and where the bus was stopped, and so the time period, because even in the morning peak, you have like morning peak uh, during the school time, and also after the school time. Like for example, in this case, we captured the data from 6:30 to 7:30, and also from 8 to 9. So we have that information, and so we are modeling this for the Colombo direction, so that also that was captured. So this is the data that we have. So from this difference between the arrival time and the departure time, we can get the dwell time, or the stopping duration. Now, if you can see, this data set is arranged in such a way that you can find the stop times for each bus routes, from which we can later get the um, data for the bus dwell times. Now, the point here, the initial point that I was making was that for a given route, you have a particular bus stops that are assigned, and they will be work, or rather we have to give it in a particular sequence. Now I have listed those, so let me bring those to the script quickly. So let me call those as, so my first element, bus stops, right? So if you look at here, so the 100 and 100 have pretty much served the entire bus stops. But if you take 255, 83, they serve separate stops. And you have long distance bus stops. They will be more like a skip stop operation ideally. And the other bus stops, like for office transportation and schools, will have taken a couple of bus stops within the route, right? So this name actually has to be uh, equal to the name of the stop in your SUMO additional file. If not, later we will have some issues, but ideally speaking, those names has to be matched, because we are stopping the bus on that particular stop location, and this text has, or this string has to be exact. So let me quickly, like, minimize this, and then we can move to the next one. Now the uh, next thing is that we need to sort of bring in the characteristics of different bus routes, and sort of mention in such a manner that we can later refer them when we are developing our script. So the best way that I've thought, or I've uh, sort of kind of tried and this worked, is that you can get all the bus attributes, or the route number and the route's characteristics, or the bus characteristics, into a nested dictionary in Python, right? So let me say this as Right. So let me bring that straight away. Um, right. So if you look at this, what we actually have is mm, the root number as the main key of the dictionary. Right. So you can add as many as you want depending on how many roots that you have. Uh, and then you will see different headway distributions, right? Uh, Now that can be taken from the survey data itself. Now we've gone through the data and we have found out that the route number 100 on average every once in every 2 minutes a bus will enter to the network. So that is 120 seconds. And that is consistent throughout the 3 hour period, right? So we run this simulation for 3 hour period. And then we capture some metadata like the route information and obviously the stops that was captured earlier on this list, and then the type of operation which we will be useful later, and the starting edge of the route and the ending edge of the route. Now that those are again uh, coming from your simulation, right? uh, so the starting edge for route 100 would be this one, right? So the ending edge will be somewhere in the upstream. Now, similarly, you can define everything, but there's a one, something else that I wanted to show. Now, if you take the long distance buses in the first, uh, you know, first half, or rather, let's say within the first 2 hours, buses will come in one and like 90-second headway, and after that once the rush time is over, the bus will basically sorry, it will the other way around, right? So here you have a shorter kind of longer headway, and in the last hour, or rather 8 a.m. to 9 a.m., you have a shorter headway. Now here also the other bus type, or rather the office and the school transportation, you can see uh, in the morning you have a very short headway with 80 seconds, and after, let's say, after 8 a.m., most of the demand is served, and therefore basically you can see once in every every 4 minutes a bus would arrive, right? So likewise, depending on the route that you are looking at, those route information can be captured and given um, as a list of dictionaries like this, right? So let me close that as well, right? So then actually now we can uh, capture, or rather start generating the uh, trips, right? Now for that, actually we need to first what we did here was we need to get the bus trips. Now initially we did a sort of a analysis on it, and we captured the stop times and everything, and then we have taken it into a uh, pickle file, um, and saved it, right? So we'll be reading that file straight away. So let me get that file as well. Right. So I will keep it. Yeah, let me. keep it in here as well, that in here, right? So now this has all the information about the about our routes, right? This is specifically needed for us when we are calculating the stopping time. So we will come back to that, or we will rather touch it in a later point. But essentially speaking, we have to load that particular file at this stage. So so that will be, so for that we need actually pandas. So let me import pandas for that. And then I can say bus strips. Can read this pickle file where this one, right? So let me quickly, yeah, so this is the file, right? So then what we are going to do is we are going to create a data frame, a pandas data frame, such that all the information that we need to capture here are sort of recorded in a data frame. We want to get the timestamps which the bus will, or all the buses, if you consider, will come into the simulation. Now that will be changed based on the route, because different routes have different headways. So sorry, that is the depart time. Now based on the depart time and the bus route and the starting time of the headway and ending time of the headway, we will create a unique ID, and incrementing unique ID for a given bus route. Color, of course, we won't be considering at this stage, but we also will consider the starting location and ending location, which is actually captured already in here, right? So then the bus stop and the stopping duration. So we have the bus stop, but what we don't have is a stopping duration. We will do a calculation from the data that we have, from the empirical data that we have, and do that calculation as well. Right. So now that is what we are going to do. So therefore, we will, in order to, before actually start creating the, so let's say this as generate bus trips data frame. Now for this, actually, first thing that we want to do is we want to initiate set of empty list for our variables. Now that those are, let's say we want to capture the departure times. So let's call it as an empty string, and then the vehicle IDs. And then we also need the bus type. Let's say whether in our case, that is whether to capture the different characteristics of the bus, because we have short distance, long distance, and other buses. And the starting edge, right? So where actually the route starts, and we also need end edges, and then we need the bus stops. Now here actually what we are going to capture is a list of lists, right? So we'll be capturing a list inside this list, and the stop times, right? That is also will be a list of list. Now we initiate this empty list And then what we do actually is that we want to iterate over this dictionary of the bus stops, or rather bus attributes, let's say, and then generate these values and sort of populate these lists, and then finally convert it to a data frame. So let me call this part as, let's say, iterate over the routes, right? So so the way I iterate over this is that I iterate over the dictionary. So it would be bus attributes dot items. So this is the element, or rather the iterator that I'll be using. So there you have the key and value pairs, right? So my key is route number, and the value, I would say it's route details. So I iterate over these two values. Here you also you need to have an in. So then let's say, let's quickly, like, do a print route number, route details, right? So you can see this is your route number, and all the other information are in another dictionary, which I can also slice depending on my requirement. Now what I'm going to do is I'm going to iterate over this headways, right? Because it's a list of dictionaries. Most of them has one element, but when you have a change in the headway, you have more than one elements there. Case in point, the other one here, other routes, right? So you have two different types of headways. So essentially speaking, the vehicle departure times that has to be generated, let's say for the other route, is initially goes with 80-second steps, and later it will shift to a 240 steps. So we need to iterate over this again. So we need to have a sort of a kind of another loop to iterate over this, right? So I would say this as for headway in route details, and route details will be this dictionary, and I'll be iterating over the headways, which will give me a list, right? So here I will consider capturing these depart times. Now before actually capturing them, I need to have another set of another two lists, empty lists, to be initiated to capture those values that are generated there. So let me call them as sub departure times, again an empty list, and then I have sub vehicle IDs, again an empty list. So as I iterate over these headways, right, most of them have single element, so you just iterate only once, but cases like here you iterate twice. So then what you do is you have to generate route depart times. Now for that we can use numpy's a range. So therefore let me import numpy as np, and then I will be using numpy a range for this, so that you need the starting time. So that is actually I can get it from the headway, the start time, right? So I can use the headway, which is this, because those are this headway represent one element of the list. So I can access the headway, and then I can from there get the start time, and as the stop time, or rather when to stop generating, or the culmination point would be um, from headway I can get the end time. in time. And then also I need to add the step, or what's the step size that I want to take the increments. That is actually a headway, right? So my step is actually now headway, right? Uh, so this will give me route depart times, and I also want to generate uh, let's say route vehicle IDs, right? Because I want unique IDs. Now for that, I can create a list comprehension where I can say in a F string, I can generate something like this. I can generate route details. From route details, I can get the yeah. So from route details, I can get the route information, right? So that will tell me like which route was that, and I also want to have the starting time and ending time. Let's say from headway, I get the start time and also I get the end time. So these things will be concatenated, and also I want to increment it with a number. So let me call that as I plus 1. Now this I plus 1, we can define the I. So that is for I in departure times in so route departs, right? So I will be iterating over this particular list, and I capture the I and the depart time. And basically I won't be considering the depart time, right? So basically I can ignore that, right? So let me yeah, okay. So let me print route route uh, okay, I'm sorry, it's route number, and I can capture the print route sorry, route depart vehicle IDs, right? So if I run this now, you can see yeah, so you can see a bunch of depart times and also the corresponding ID, right? So this would say on this is the time which the bus enters, and this would say the long distance bus from 0 to 7,199 headway interval or duration, the first bus that is entered there, right? So we have that now. Now what we then actually need is to get the other information for a given bus route, uh, or rather before moving there we need to append these captured values into these particular empty lists that we create. So let's do that. So we can say sub departure times, and we can extend it from route depart. So the list will grow as we iterate. And then we can say sub vehicle IDs. You can also extend that using route vehicle IDs, right? Then we can exit from this for loop and go back to our main for loop. And there we can basically say our rest of the columns we can capture. So first column that I would be interested in, bus type. Now bus type is actually, we can get the bus type from route details, and from that the bus type. And I want to repeat that until uh, till the length of this particular list, because I need, in order to create, for me to create a data frame, it's essential to have lists with equal number of length, right? So I want to capture that. So I would be repeating this. So I would take this, because this is basically a string what you get inside. So I can pass it again as an element in a string, and I can repeat it until the length of the particular this particular list, right? So obviously this size of the list will be vary depending on the depending on the headway basically, and from that you can capture that, right? So similarly we can get the other ones. Starting edge also I need to capture. So let me similarly, yeah. So I need start edge and I need end edge. Um, Also, I need the stops, right? Okay, so these things I need. Okay, so okay, so those things I need. So let me quickly get those, so I can basically copy this and paste it. But the only thing that I am going to change is things that are here. So start edge, and here that would be the end edge, and then the stops, right? Because we know the stops, and then stops will be inside a list, and that list will get repeated, right? So then that's basically done. And then what we have to do is we have to extend, or rather put all those things into our uh, main list that we want to capture. So let me call this as, let's say, extend, right? So let me close this. Right. Okay. So then that would be extended by the sub departure times. This would be extended by the sub vehicle IDs. And this would be extended by the bus type. And again, start edge. Extend by the end edge. and extend by the stops. Right. So stop times we haven't captured yet, or rather calculated yet. So let's keep it uh, as the next task. Now, there what we are going to do is we are going to use a library called because from each, we can get the stop time distribution, right? So this is for all the buses regardless of their route. We captured the yeah, sorry, this is long distance, but similarly we have done that exercise for short distance and everything. But if I quickly come to the point, what we then do is we get the we have to get the distribution by route. So let me quickly scroll up and see whether I can find it. That was here. Where was it? Yeah, there it is. Right. So let's say I did this in this example for short distance buses. Right. So depending on the stop type, you can fit a distribution, and from that distribution we can draw values. Now the distribution or the library for that what we use is called distfit. uh, it's a pop that library is useful for that because it will help you to automatically understand uh, the underlying distribution for that data, and from that basically you can get it done, right? So you can, by running a simple couple of lines, we can get it done. um, Sorry, where I can, let me find it. Yeah, detect best fit, probably that, yes. Yeah, so within this kind of a, yeah, operation you can or rather using those methods you can quickly get it done, right? So the way that um, I did it also, right? So let's say for a single case, that is you get the actual or the empirical data to a numpy array, and then that numpy array will be passed, or rather using that numpy array you fit transform, because from that it will evaluate the possible distributions and find the best one. And once you know that, you can use that to generate the number of elements that you want. And obviously here it will be generated sometimes as in decimal values, so I wanted to make it as integers. And then here I took a decision where the dwell time does not exceed 180 seconds and does not go below than 0 seconds. So I can use the np-clip function to sort of if there are any values that were generated, if it is greater than 180, it will be replaced by 180. If it is greater less than 0, it will be replaced by 0. So that operation is what we did. So that part I need to bring it into my code. So that is what we are going to do next. And that once the stop times are generated, that will be sort of appended to the stop time list. Right. Now here what we can do uh, is for a given route, first I need to create uh, or capture the empirical stop times. That I can do by using bus strips. Yeah, the way I captured it was, yeah, let's call this as bus strips. Um, so then, so bus trips. From that, I can subset it to by route number, and I can get it the route number, right? So I can basically, I'm doing a subset, and I get those particular for a given bus route the 12 times. Actually, that is can be taken by the stop time in seconds column. So that is a column that I defined. That I can convert it to a numpy, so that I am preparing it to pass it to the disk. And then here I initiate a disk fit, right? So actually I need to import disk fit, that is from this. Yeah, so the import goes as from disk fit import disk fit. So I'm using that disk fit, and then what I can do is I can say something like this as a kind of a print statement. I can say, so I can say something like this. This is just will be shown as we iterate, so that we know that where we are actually. So then we can fit here, right, using this fit. So we created the object and using that, and we create fit transform operation, and then we pass this particular value set that will find it. And also we can pass the verbose as silent, because if not it will show uh, like a lot of unnecessary values will be printed. So I just wanted to get rid of that. So you can check the documentation and see what else you can do with it. Now what I do is I go with the I'm going to do another iteration where uh, because for each, so each depart, right, so if you take a particular bus, right, it will be stopped at those designated stop areas, right? So for each departed bus I need to calculate this, right? So therefore what I do is I can say for uh, so I can enumerate over the sub departure times that I've captured, right? That has all, for a given route, all the departure times. So I can say use something like generate stop time. That would be, I'm using this fit, which is already fitted, and I use generate, and I want to generate it let's say, so for a given route you stop it, let's say 14 times. For example, 100 bus route, you have to stop it 14 times because you have 14 stops. So you need to generate it for 14 times. That means the length of the list which holds the bus stops, right? So that is, so I can say length. I can get the route details. From that, actually I have the stops, right? So that length, so that this is an integer, so up to that many times it will generate these stop times. And then I can also use a random state here, uh, because I don't want to randomize it, because every time I run the script, I don't need to it to be sort of randomized. So I random, I would set the random state into the index, right? So that means for each depart, this random state is fixed, so that I won't be generating for all the stops the same values, but uh, for different departure, different stop times will be generated, right? Because the random seed that is passed is different because it's based on the index. Right. So then I can cap it. Say gen stop times, let's say integer cap. I can say, so I can do it as a list comprehension. So let's first do it. So I can say np.clip, and then I can say as type int. So I convert it to int, and then I can then say the minimum value would be 0 and the maximum value would be 180. That is a decision that I took. And this entire thing I need to pass to a list. And that list, since I'm going to repeat it, right? Or rather, I would be, yeah. So I want to keep it as a list because we will see this later when we transform it. That would be much more helpful. Uh, and that list, I would be appending it to my stop times. So I in it by the integer cap. So then pretty much things are done. So finally, what we have to do is we have to come out from the for loop, which is, I guess, this one. No. Yeah. So let's do like this. So let me go like this, and then let me create the final data frame. Now I can call it as root df, where I can say create a pandas data frame, and I can pass the column names. So I need to have my first column as trip ID, that is my vehicle IDs. Sorry, vehicle IDs. Then I need to have my depart times, that is depart. Yeah, I guess it's departure times. Yeah, that's departure times. And then I need my start edge. So start edges, I would be taking that list, and my end edge, end edges. And then I need my bus stops. Now this is a list. Uh, yeah, so it's a list of lists basically. And I need my stop times, which I just captured. Right. So then let's say root. Just to view this, I will save it as a CSV file. So that would be saved in the same location. So let me run this, and we'll see whether things work fine. Let's see. Yeah, so you see the for the roots are the the stopping times are fit or from the distribution, and the process was ended. So let's see the resulting file. So you get something like this, right? So you get the trip IDs, and you get the start times or the depart times, and you can get start edge, end edge, and the bus stops inside a list. And similarly, okay, there's an error, built-in method to list of number. Okay, so we have a small issue there. Let's try to fix that. Okay, let's see what went wrong there. Okay, so this fit generate for that particular length and random state as an index. Okay, sorry, here I have missed it. So probably because of that. All right. Yeah, so now you see the stopping times are also, the dwell times are generated and they are different to each other. But here there's one other thing that you can, if you can see the depart times are basically pretty much following the headways exactly, and there could be instances because of this where you can see, so the next bus 101 also enter into the simulation at zero timestamp, and here also you have the 100 first bus also entering at the same simulation step. So we can randomize this, right? So we can generate a random number and then sort of, you know uh, try to add some random offset for this. Now the way that I sort of thought of doing it was, I can create a random number and I can use a random integer. Let's say I get a value between 0 and 450. Now here the reason why I got 450 is my longest headway is 900 seconds. I took half of it. That's a choice that I made. Yeah, so I have to import random, that has was automatically done. So that's a choice I made, but if there are any better ways of doing it, obviously I we can comment on it. So I will consider that. Now once you create this random number, then what you have to do is, you can add that particular random number to the headway start time, right? So that is, you add this random number, right? So now when you run this, uh, yeah, so yeah, so then when you do this, what you get is, kind of it randomized, right? So but here you need to fix a random seed, because if not, what will happen is that no matter how many times that you run this, uh, let's say it will give you the same, I mean, it will give different values. So therefore I set a random seed. You can uh, take any value and set it. And then what will happen is, basically now you can see it starts from 699. But once it's run, actually the values will be different. Yeah, so now it's 46 and it's goes like that. But now no matter how many times you run, you get the same output, right? So this way you can basically create a data frame, right? And that data frame will have all the necessary values according to the um, documentation of SUMO. And in the next video, we will see how we can convert that um, data frame that we created into this particular format. It is pretty much same as the way or the steps that we followed in our previous video, where we got the uh, edge files. If you remember, we got our edge files like this. So in a similar fashion, we need to convert that. So in the next video, we will see how we can do it, and also how we can take the developed script, or rather improve the developed script such that things are inside the functions, right? So we'll see you on the next video.